A previously unknown 100 to 200 meter asteroid, roughly the size of Rome's Colosseum, has been detected by an international team of European astronomers using the NASA/ESA/CSA James Webb Space Telescope. Their project used data from the calibration of the mid-infrared instrument, MIRI, in which the team serendipitously detected an interloping asteroid. Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. The object is likely the smallest observed to date by Webb and may be an example of an object measuring under 1 kilometer in length within the main asteroid belt, located between Mars and Jupiter. More observations are needed to better characterize this object's nature and properties. The solar system is teeming with asteroids and small rocky bodies. Astronomers currently know of more than 1.1 million of these rocky remnants of the early days of the solar system. The NASA/ESA/CSA James Webb Space Telescope's ability to explore these objects at infrared wavelengths is expected to lead to groundbreaking new science. But a team of scientists have shown that Webb also has an unpredicted aptitude for serendipitously detecting small and previously unknown objects. We, completely unexpectedly, detected a small asteroid in publicly available MIRI calibration observations, explained Thomas Müller, an astronomer at the Max Planck Institute for Extraterrestrial Physics in Germany. The measurements are some of the first MIRI measurements targeting the ecliptic plane, and our work suggests that many new objects will be detected with this instrument. The Webb observations, which revealed this small asteroid, were not originally designed to hunt for new asteroids. In fact, they were calibration images of the main belt asteroid 10920 1998 BC1, which astronomers discovered in 1998. But the calibration team considered them to have failed for technical reasons due to the brightness of the target and an offset telescope pointing. Despite this, the data on asteroid 10920 were used by the team to establish and test a new technique to constrain an object's orbit and to estimate its size. The validity of the method was demonstrated for asteroid 10920 using the MIRI observations combined with data from ground-based telescopes and ESA's Gaia mission. In the course of the analysis of the MIRI data, the team found the smaller and previously unknown interloper in the same field of view. The team's results suggest the object measures 100 to 200 meters, occupies a very low inclination orbit, and was located in the inner main belt region at the time of the Webb observations. Our results show that even failed Webb observations can be scientifically useful if you have the right mindset and a little bit of luck, elaborated Müller. Our detection lies in the main asteroid belt, but Webb's incredible sensitivity made it possible to see this roughly 100-meter object at a distance of more than 100 million kilometers. The detection of this asteroid, which the team suspects to be the smallest observed to date by Webb and one of the smallest detected in the main belt, would, if confirmed as a new asteroid discovery, have important implications for our understanding of the formation and evolution of the solar system. Current models predict the occurrence of asteroids down to very small sizes, but small asteroids have been studied in less detail than their larger counterparts owing to the difficulty of observing these objects. Future dedicated Webb observations will allow astronomers to study asteroids smaller than 1 kilometer in size, providing the necessary data to refine our models of the solar system's formation. What's more, this result suggests that Webb will also be able to serendipitously contribute to the detection of new asteroids. The team suspect that even short MIRI observations close to the plane of the solar system will always include a few asteroids, most of which will be unknown objects. In order to confirm that the object detected is a newly discovered asteroid, more position data relative to background stars is required from follow-up studies to constrain the object's orbit. This is a fantastic result which highlights the capabilities of MIRI to serendipitously detect a previously undetectable size of asteroid in the main belt, concluded Brian Holler, Webb support scientist at the Space Telescope Science Institute in Baltimore, U.S. Repeats of these observations are in the process of being scheduled, and we are fully expecting new asteroid interlopers in those images. European astronomers using the James Webb Space Telescope have detected a previously unknown asteroid about the size of Rome's Colosseum in the main asteroid belt between Mars and Jupiter. The asteroid, measuring between 300 to 650 feet, 100 to 200 meters, in length, is the smallest object observed to date using the telescope, the U.S. Space Agency NASA said Monday. The European astronomers serendipitously detected the asteroid, NASA said in a statement, adding that more observations would be needed to better characterize its nature and properties. "We've completely unexpectedly detected a small asteroid," said Thomas Muller, an astronomer at the Max Planck Institute for Extraterrestrial Physics in Germany. It was detected during calibration of the telescope's mid-infrared instrument, MIRI, which operates in mid-infrared wavelengths. Webb's incredible sensitivity made it possible to see this roughly 100-meter object at a distance of more than 100 million kilometers, Muller said. Webb, which has been operational since July, is the most powerful space telescope ever built and has unleashed a raft of unprecedented data as well as stunning images. One of the main goals for the $10 billion telescope is to study the life cycle of stars. Another main research focus is on exoplanets, planets outside Earth's solar system. Webb was not designed to look for small objects such as the newly discovered asteroid, but Muller said its discovery suggests that many new objects will be detected with this instrument. While astronomers and engineers were trying to calibrate one of the James Webb Space Telescope's instruments last summer, they serendipitously found a previously unknown small 100, 200 meter, 300 to 600 feet asteroid in the main asteroid belt. Originally, the astronomers deemed the calibrations as a failed attempt because of technical glitches. But they noticed the asteroid while going through their data from the mid-infrared instrument, MIRI, and ended up finding what is likely the smallest object observed to date by JWST. It is also one of the smallest objects ever detected in our solar system's main belt of asteroids. "We, completely unexpectedly, detected a small asteroid in publicly available MIRI calibration observations," explained Thomas Muller, an astronomer at the Max Planck Institute for Extraterrestrial Physics in Germany, in a press release. "The measurements are some of the first MIRI measurements targeting the ecliptic plane, and our work suggests that many new objects will be detected with this instrument. The asteroid is not yet named, as follow-up observations need to be done to confirm the discovery. Additionally, more observations will be done to better characterize this object's nature and properties." This finding was unexpected because astronomers weren't sure JWST had the capability to find asteroids this small. But this detection showed otherwise. What's more, based on this finding, astronomers suspect that even short MIRI observations close to the plane of the solar system will always include a few asteroids, most of which will be unknown objects. This is reminiscent of the early calibration images in March of 2022, where previously unseen background galaxies were showing up everywhere. Jane Rigby, JWST Operations Project Scientist, said, "Basically, everywhere ever we look, it's a deep field." So, JWST's infrared capabilities should be a boon to detecting some of the hardest to find asteroids. Scientists estimate the asteroid belt has between 1.1 and 1.9 million asteroids larger than 1 kilometer, 0.6 miles, in diameter, and millions of smaller ones. Most of the undiscovered asteroids are the smaller ones, less than 100 kilometers across, which are more difficult to detect. This is a fantastic result which highlights the capabilities of MIRI to serendipitously detect a previously undetectable size of asteroid in the main belt, said Brian Holler, Webb support scientist at the Space Telescope Science Institute. Repeats of these observations are in the process of being scheduled, and we are fully expecting new asteroid interlopers in those images.